All right, so your job is to identify all localized lone pair and the localized lone pair too. Okay, you have to be able to identify them. All right, start with the imidazole on the top left corner. All right, for sure, this guy have two lone pairs. Can you tell though which one localized, which one delocalized? Okay. All right, let's take a look. The first on the start with nitrogen on the left side. This guy here. All right. This nitrogen and sp2 already participate in forming pi bond. Okay. So basically, the p orbital is already used to form a pi bond. This lone pair totally it has to pointing out like in an sp2 orbital. Okay. So this lone pair is localized. Uh, in contrast to this lone pair is not localized. Here, what happened? If you look at this ring real quick, ignore this lone pair for now. Okay, we don't use it anymore anyway. All right, how many pi electrons are there? 1, 2, 3, 4. All right, that's anti-aromatic. To make this guy an aromatic compound, need 2 more, 5 and 6. That's a 6 pi electrons. Okay, so this guy would become aromatic compounds if this nitrogen take this lone pair, put into the ring. All right. So basically, this lone pair is on in a p orbital and delocalized in the ring. You can draw resonance structures. If you're not sure what I'm talking about, you can see there's a double bond right here. This lone pair is an allylic position, and you guys know allylic lone pair is delocalized. Okay. All right. Move on to AC pi on the right side. For sure, there's a one lone pair right there. All right. Let's count real quick. Can this guy be aromatic? 1, 2, 3, 4, 5, 6. That's already good. If you put this one lone pair, 2 electrons into the ring, you would have 8 electrons, right? And that's make this compound anti-aromatic. So to avoid being anti-aromatic, this nitrogen have no option but put this lone pair in an sp3, turn itself to an sp3 hybridize. Don't let this lone pair conjugated in the ring. Okay, so this lone pair is localized in an sp3 orbital. Okay, and that's the non-conjugated nitrogen. All right, down here. All right, so we have a lone pair in the ring. That's lone pair. Okay. By the way, so don't get confused with the carbon and oxygen outside the ring. This guy's outside the ring. Do not count it. All right, do not count it. This is pi electrons outside the ring. We look at the electron just inside the ring. All right. All right, let's see if this guy aromatic or not. 1, 2, 3, 4. All right, that's not yet, but need 2 more to be aromatic. 6, right? 5 and 6. That's aromatic compound. So this nitrogen will put this lone pair in a p orbital and let it delocalize with the other p orbital in the ring. Right? There's a p orbital right here. Although this 2 pi electron is outside, but the p orbital is actually in the ring. Okay, you can count as a p orbital. The whole thing is has a conjugated pi system. All right. Okay. Okay. All right. Now we're going to move on to another type of aromatic compound called polycyclic aromatic compound. So we have multiple rings.